So, hello everybody, and welcome to the sixth seminar in the UNICAF University Statistics Camp series, or UUStats. Today's seminar is on correlation and linear regression. We're going to play a video pre-recorded by Dr. Mary Mandiringana. Dr. Mary, I know that you might be having internet troubles today, but could you turn on your camera and hello? Can you hear us? Excellent. Would you like to introduce yourself, Dr. Mandiringana?
Oh, you can see me.
We can see
Okay.
you, yes.
Okay, I'm Dr. Mary Mandiringana. I'm the one who will be doing the linear regression and correlation seminar, statistics seminar. So I hope you will enjoy it, you start to understand it. A lot of people, they think it's quantitative, but also in qualitative, you use regression and correlation. So when we start, we'll be seeing the recordings of the regression and correlation. Then soon after that, there is a question and answer session. Thank you,
Excellent.
Sebastian.
Yes, as
Okay.
Dr. Mary said, we've got a question and answer session after the presentation. The main seminar, which we'll play a recording of, is about 30 minutes. If you have any questions, just post them in the Q&A section at the bottom of your Zoom controls. Also, don't raise your hand because we've got no way to respond to that, as we can't include you in chat or promote you to a panelist. So anything you have that you wish to tell us in the Q&A section. Okay, we'll play a video now, and then we'll get to the Q&A.
Okay, good afternoon. I'm Dr. Mary Mandiringana. I'm going to be talking about correlation and linear regression. What I'll be talking about, in fact, I'll do the introductions of correlation and linear regression, and then later on, I'll also talk about the interpretation of all these methods. These methods are normally used in quantitative methods, but correlation can also be used in qualitative methods. So when comparing two variables, these two questions come to mind, like profit and advertising. Is there a relationship between these two variables? If there's a relationship, how strong is that relationship? And normally we answer with regression and correlation at the same time, because regression answers whether there's a relationship, and then correlation answers how strong the relationship is. So correlation and regression, I will be calling regression or linear regression is still the same thing altogether, are the two most commonly used techniques for investigating the relationship between quantitative variables. I'll be starting with correlation, and then a lot of people might not even understand it, or you already know, so I will make on my own definition. So correlation is a statistical technique to ascertain the association or relationship between two or more variables. So correlation analysis is a statistical technique to study the degree and the direction of a relationship between two or more variables. And how do we use correlation, and why do you use it? Correlation analysis helps in deriving precisely the degree and the direction of such relationship. And the effect of correlation is to reduce the range of uncertainty of our prediction, as a prediction based on correlation is more reliable. As we normally deal with figures when you're doing correlation, it also contributes to the understanding of economic behavior, aids in locating the critically important variables on which others depend. Still continuing with the uses of correlation, it is economic theory and business studies show relationships between variables like price and quantity demanded. Then also like advertising, expenditure, and sales promotion measures. The measures of a coefficient of a correlation is a relative measure of change. Some are asking, what is the correlation coefficient? It is the specific measure that quantifies the strength of the linear relationship between two variables in a correlation analysis. So today's business comes across many activities dependent on each other. Usually large businesses use 2 or more variables, and then you find that smaller businesses, they use less variables. So the types of variables we will be looking at in the correlation are dependent and independent variables. These two variables can move in the same direction, decreasing or increasing, or they can and have an increase is accompanied by a decline. When it increases, it can be accompanied by a decline also. Then for example, the dependent and independent variables which are normally used in correlation, we might find that a family income and expenditure. Explaining to this family income and expenditure, you find that the more you earn, the more a family earns, you end up spending more because you've got a lot in your disposal. Then the price of a product and its demand. You know, the more a product is demanded, the higher the price it goes. Then advertising, expenditure, and sales volume. Now, when you're advertising, you use a lot of money for the advertising. And then at the end of the day, we normally expect that the sales volumes will also go high. So if two quantities vary in such a way that movements in one are accompanied by movements in the other, then these quantities are said to be correlated. Go to types of correlation. Correlation is described in many different ways, but let's look at this. Positive correlation. What do we mean by that? The two variables change in the same direction. That is positive correlation. Then what is negative correlation? It's when the two variables change in the opposite directions. It's like one going this way and the other one going that way. Then we have where there's no correlation or zero correlation. There is no association or relevant relationship between these two variables. Then we look now at the types of correlations. There is linear correlation. This is if the amount of change in one variable bears a constant ratio to the amount of change in the other variable. Then correlation is said to be linear. If such variables are plotted on a graph paper, all the plotted points would fall on a straight line. Now, when you draw a straight line on a scatter graph, that's when all the plotted points will be falling on that straight line. But when it's nonlinear, if the amount of change in one variable does not bear a constant ratio to the amount of change to the other variable, then correlation is said to be nonlinear. If such variables are plotted on the graph, the points would fall on a curve and not on a straight line. As linear correlation, it's a straight line, but nonlinear correlation now is not straight, it falls on a curve. Then when we talk about linear correlation, I can give an example here that it means if one variable is increasing, the other increases too. That is a positive correlation, as I have already explained. I might give an example. Normally you find that height can increase also with the weight. When someone is 158 centimeters, you find that the weight is 60 centimeters. And the other one who is 160 centimeters will be adding more of the weight. Then this we call it, it's a positive correlation. Then when you talk about negative correlation, when both variables vary in opposite direction, one is increasing and the other is increasing, that is negative correlation. Let me say some examples. Let's say the more it rains, the less you can water the garden because it's already wet, so there's no need to water the garden. The more you cook at home, the less you might eat out because you've got already cooked food. So there's no really need to go and eat out. And again, another example is the lower the temperature, the more clothes you wear because you're feeling a little bit cold. So you need to put more clothes. So that is negative correlation. Then let's go to zero correlation, which we can say no correlation in another way also. There is no relationship between the variables. Thus, a change in value of the other variable does not influence the other. It does not influence the other. For example, the correlation between the weight of a person and his intelligence is no zero correlation. These two things are not related at all. Whether you've got too much weight, it doesn't mean that you are going to have more intelligence, or you are slimmer, you won't have any intelligence at all. This is no zero correlation. Then when you look at linear correlation now, it's usually represented by a straight line on a scatter plot. I think some of you already know. I'm not going to go into details on the drawings and everything about this straight line. I'm just going to be explaining and telling you about some of the analysis and the important points in linear regression and correlation. So for example, let's consider the relationship between the hours spent studying and the grades obtained in a class. If the student relationship is linear, we can expect that the more time a student spends studying, the better grades they will get. And then another example, if it is assumed that to produce 1 unit of finished product, we need 10 units of raw materials, then subsequently to produce 2 units of finished products, we need double of the 1 unit. So this will be linear correlation. Then let's talk about non-linear correlation, which means it's not straight. For example, if we double the amount of advertisement expenditure, then sales volumes would not necessarily be doubled. You can spend money advertising, but it doesn't mean that the sales volumes would be doubled. As the graph shows here, then we look at the methods of correlation. There are a bit more of the methods of correlation, but I'm just with the time we have, I'll just look at Pearson correlation, Kendall-Rank correlation, and Spearman correlation. The most popular one, which is being used these days, is Pearson correlation. So we talk about Pearson correlation. Pearson correlation is utilized when we have two quantitative variables, and you wish to see if there is a linear relationship between those variables. This method is the most common method to use for numerical variables. It assigns a value between -1 and 1, where 0 means there's no correlation, and 1 is a total positive correlation, and -1 is total negative correlation. These numbers, the -1, the 1, and 0, you will normally find them in the correlation matrix. Then we look at Kendall's rank correlation. It provides a distribution-free test of independence and a measure of the strength of dependence between two variables. Then Pearson product moment correlation. Although you'd normally hope to use a Pearson product moment correlation on interval or ratio data, this Spearman correlation can be used when the assumptions of the Pearson correlation are markedly violated. Then, as we are talking about, this scatter diagram is the most important when you're using correlation, even on regression, as you will see later when I start to talk about regression. A scatter diagram is used to examine the relationship between the axes, that is X and Y, with one variable. in the graph, if the variables are correlated, then the point drops along a curve or a line. A scatter diagram or a scatter plot gives an idea of the nature of relationship. There are a lot of diagrams which they were showing now. So we look at the scatter plots and correlation at the same time. As we indicated that correlation indicates a relationship, connection between two sets of data. So the first one will be like a strong correlation. What is a strong correlation? And then we look at, we find a weak correlation. A strong correlation is where all the points are near the straight line. Then a weak correlation, you find that there are some which are a little bit out. Then a strong negative correlation is, that means the correlation is negatively affected. And then weak negative correlation and moderate negative correlation, and then no correlation at all. Then whenever you do a correlation, you have like from the other programs which you learn on how to use the SPSS and how to enter and the data and come out with a correlation matrix. This is a table that shows the correlation coefficients between several variables. I'm not going to go much into these details because I'm not like lecturing. I'm trying to do a seminar and give you much information about correlation and regression. So an example of a correlation matrix, it's a table which shows the correlation coefficients, several variables related to education. For example, we were talking about in the previous, as hours spent studying, you might find that they improve the exam score of the student. But hours spent sleeping, they might negatively affect the exam score because you are spending more time sleeping than the one who is preparing for the exam. Then the correlation matrix, this is a statistical technique used to evaluate the relationship between two variables in a data set. The matrix is a table in which every cell contains a correlation coefficient, where one, as I said, is considered a strong relationship, that if it's a one, if two variables, then they come up with a one, that means they've got a strong relationship. Then a zero, which means all neutral relationship, and then -1, that there is not a strong relationship between the two variables or three variables. I think I've said enough about correlation. It's all about entering the data and coming up and be good at interpreting the correlation matrix. Then we go to regression. When I talk about regression, I mean linear regression. So the meaning, regression analysis now is a statistical tool to study the nature and extent of functional relationship between two or more variables. As we will see later, you find that if there are more variables, it will now be called multiple regression. And to estimate or predict the known values of the dependent variable from the known values of the independent variable. So regression is also about the dependent and independent variable. I will be explaining more into that. This was developed a long time ago by Sir Francis Galton in 1877. So we look at the types of regression now. There is simple regression, multiple regression, and then linear regression, logistic regression, to name but a few. Though we are much interested in linear regression, we have to understand a little bit from where is it starting from, the simple regression and the multiple regression also. So when you talk about simple regression methods, they help you estimate the relationship between a dependent and the one independent variable. For example, you might use simple regression to compare the connection between umbrella cells, that would be the dependent variable, and the amount of rain a meteorologist focus, which is now independent variable. So looking at this example, when it is raining more, you find that people buy more umbrellas because they don't want to get wet. So they use more umbrellas. But during the summer, where there's not much of the rain, and it's not like you like here in Africa, you might still continue using umbrellas also. But in other countries, you find that the sales of umbrellas, they go down because there's no use to use these umbrellas. Then we go to multiple regression analysis. This is a method which helps you determine the relationship between a dependent variable and more than one dependent variable. The variables will be many on a dependent variable. Adding more independent variable makes for a more complex regression analysis study, though it often generates more specific and realistic results. It's more accurate when you use multiple regression because you are using a lot of variables. And with the use of the SPSS and other which we use, it's so easy to use all those multiple, many variables to come up with a better regression, multiple regression model. For example, you might evaluate if more umbrellas sell when the meteorologists focus rainy weather, specifically during spring or comparatively across all seasons. Or we might review salary earnings for education, experience, and proximity to a metropolitan area. Then let's now talk to the one we are interested in more, the linear regression analysis. This one is a simple regression type that requires to create a hypothetical line that best connects all data points. You determine the best fit of the line. I'll talk about what is the best fit of the line later with linear regression and establish a predictor error between the predicted value based on the line and what's actually observed. Is the predicted value based on the line and what's actually observed. The disadvantages of linear regression is the potential for outliers in the data. So it's frequently used for small data pools of information or predictions. This is because some data points may not fit neatly into the regression line. Then we go to logistic regression. Logistic regression helps measure the relationship between dependent and independent variables. Though it does not correlate between independent variables, you often have a large set when using logistic regression, and the dependent variable is usually discrete, meaning that you cannot count all values within a finite amount of time. So with logistic regression, the target variable typically only has two values, and the sigmoid curve shows the correlation. Then we talk about the uses of regression. That's our linear regression. It provides estimates of values of the dependent variables from values of independent variables. Then it's used to obtain a measure of the error involved in using the regression line as a basis for the estimation. The error term can be found in the regression equation. And then we can obtain a measure of degree of association or correlation that exists between two variables. It is highly valuable true in economies and business research, since most of the problems of the economic analysis are based on cause and effect relationship. So let's now talk about the dependent and independent variable, which I've been saying from the start, from the correlation. So the variable that forms the basis for predicting another variable is known as the independent variable. And the variable that is predicted is known as dependent variable. So let's give an example. If we know that two variables, price X and demand Y, are closely related, we can find out the most probable value of X for a given value of Y, or the most probable of Y for a given value of X. So there are also regression lines. Regression lines and regression equations are used synonymously. Regression equations are algebraic expression of the regression lines. So let's talk about the regression line first. A regression line is a straight line that describes how a response variable y changes as an explanatory variable x changes. A regression line can also be used to predict the value of y for a given value of x. So as we are talking about the explanatory, I thought, let me bring the regression equation. How can we talk about regression without bringing in the regression equation? So on the regression equation, find that y is equal to a plus bx plus error. Y in it is the dependent variable, and a is the intercept. B is the slope, and x is the explanatory variable. And then E is the error of the term.
اتفضلي خلاص.
X. Predict his way of presenting it. So if the slope of the line is positive, then there's a positive linear relationship. That is, as one increases, the other increases. But if the slope is negative, then there's a negative linear relationship. As one increases, the other variable decreases. Then we have to talk about the line of best fit, which is like one thing which is always talked about and which you have to interpret when you do regression. The line of best fit is a line that goes roughly through the middle of all the scatter points on the graph, as you can see. The closer the points are to the line of the best fit, the stronger the correlation is. So the scatter graph shows a strong positive correlation. As you can see that the points are nearer to the line. Then, as we have already talked about regression and correlation, sometimes it's a bit confusing to understand the difference between correlation and regression. So I have done a table here with the difference. So what is correlation? I'm going back, it's like a summary. It measures the degree and direction of relationship between the variables. Whilst regression, it measures the nature and extent of average relationship between two or more variables in terms of the original units of the data. Then the second one, it is a relative measure, the correlation, showing association between the variables. Whilst regression, it is an absolute measure of relationship. Then correlation coefficient there is independent of change of both origin and scale, whilst regression coefficient is independent of change of origin but not scale compared to correlation, not scale. Then correlation coefficient is independent of units of measurement, whilst regression coefficient is not independent of units of measurement. We continue then on correlation, there is the expression of relationship between the variable ranges from -1 to +1. Whilst the expression of the relationship between the variables may be in the forms of like, that is a regression equation. Y is equal to a plus bx and the other one. So that's the difference. On the correlation is a relationship between the variables which range from -1 to +1. Whilst on a regression model, it is normally an equation. So on correlation, it is not a forecasting device. Whilst in regression, it is a forecasting device which can be used to predict the value of dependent variable from the given value of independent variable. Then finally, there may be zero correlation, such as weight of wife and income of husband. This is a bit tricky. The weight of the wife and then the income of husband, this will never correlate. But in regression, there is nothing like a zero regression. Thank you so much.
So, thank you very much for that presentation, Dr. Mandiringana. We're now going to proceed with the question and answer section. So if you have any more questions that you haven't yet posted in the Q&A, please do so. You'll find the Q&A just at the bottom of your Zoom bar controls. So,
yes, thank you so much, Sebastian. I've been trying to answer some of the questions because here where I am, there is a problem of electricity, so it's going at times. So I've tried to answer some of the questions in the Q&A, but if there are still any more questions, the students, can you please write? Thank you, Sebastian.
okay. Let's go over the questions which you haven't answered first, and then we can also get to the ones, or let's get to the ones asked earlier in case somebody else wants to know the same point. So it was looking at the graph of weak correlation, moderate correlation, both seemingly related. How can we technically differentiate them? And Dr. Mandiringana responded already. Would you like to read your response, Dr. Mandiringana?
I can't find it. Can you read it for me?
Okay,
It seems
sure,
like when
of course.
electricity went, it all
It all
yeah,
goes.
can
Okay,
you
the
help?
difference is that in weak correlation, the points are not clear, are not near the straight, but the other, they are scattered on the line. So there's that. And hi, can I code and use Likert scale on logistics regression for testing of my hypothesis?
Can you redo it again? That one is not on my, I'm seeing another one from Seth, yeah.
Of course.
Yes,
Hi,
can you read it?
can I code and use Likert scaling on logistics regression for testing of my hypothesis?
Yes, you can use, though we are not talking much about logistic regression here because we were concentrating more on the linear regression. I think that's one part of seminar which we might think of bringing in the next time, but you can still use it also the Likert scale for logistics regression, because logistics is used to predict like the category dependent variable. So when it's, for example, it might be used as a yes or no or a 0 or 1, like in the insurance company. So that's when you can use also logistics. I think I'm also trying to answer a question there, Sebastian. Can I just continue? Under which condition can we use a logistic regression? Like, furthermore, what is the nature of the graph of logistic regression and what is significant and real application? That one is a bit very difficult for me to answer like the way I'm saying about it now. But the nature of the graph of a logistic regression, it has a curve. That is the difference between it and the linear regression. Linear regression has got a straight line, but logistic regression has got a curve. And as I said, for instance, it's used in insurance companies deciding whether or not to approve a new policy based on driver's history, credit history, and such other factors. So that's the difference between it and linear regression. But unfortunately, on this seminar, I was mostly concentrating on linear regression. Then we come to another one: how important are variables on research topics? Do we need to have the variables on acceptable topics always? Yes. as much as you start, when you're using like a regression or correlation or quantitative, we say, you look at the variables. As I said in the first place, they are dependent and independent variables. So these independent and dependent variables, you come up with a conceptual framework. I think when you're doing your research, you understand that you come up with a conceptual framework. The conceptual framework now relates the independent variable to the dependent variables. So when you come up with the conceptual framework, you will be also relating to the research topic. It's like you're talking about the business, the financial performance. What is the variable I'm going to use for measuring the financial performance? Mostly we look at gross profit. We look at net profit. So those are the variables. And for us to come up with those variables, what are we looking at? What are the independent variables now? So it is important to look, when you're coming up with variables, you relate it from your research topic. Then there is another one. Good afternoon, please. When will all the modules be uploaded on the website to go over the recording? Sometimes I think that one is for you, Sebastian.
That one is for me, yes. I can read you the questions as well if you like, whatever you prefer.
Okay. I think you can read for me, yes. Okay,
I'll read you the questions, then you can answer them just to separate it out a bit. On the VLE, recordings are normally uploaded within a month. Often it's faster than that. But we do say in a month just to cover ourselves. You will find the section on the VLE in the Student Help Center under the Research Hub, which is just above the Doctoral Studies section. The first 4 seminars in the UU Stats series are already up, and the next 2 will be up by the end of April. Okay, next question is similar. Can this be sent to our emails before we forget this important information? No, but it will be on the VLE within a month. So that's the same question. And the humorous comment you made at the end, I am of the view that our assumptions on correlation need to be tested. So in your example, the income of the husband can be the means of increasing the weight of the wife through food purchases.
Thank you, Sebastian. As you called it, it's a humorous one. I also answer it in a humorous way also. I don't know how the testing will be, because as academics, we're very particular on what research topic we are dealing with. Maybe it's a social one, but it can be tested, and we need to see if the husband's income relates to the woman's weight also. Thank you. It will be an enjoyable research to do. I think in other schools, not in my accounting and finance. Thank you.
Now, this next question, it's not really a question. I don't fully understand what is trying to ask, but maybe it'll make more sense to you, Dr. Mandilingana. I mean, we can moderate negative correlation graphs. So there's no actual question there.
Yeah, I'm not really getting it also.
Yeah.
Maybe the one who sent that can also
ask the question again and we can answer it. So in SEM, is it possible to do regression and linear analysis?
That one, I think, are you getting, Sebastian, what they mean by SEM? I'm trying to get it. SEM?
I think it might be a software.
About those softwares, I think, Sebastian, you once did some earlier seminars which were talking about that in SEM. Mostly, I know, I wouldn't want to go into that one into the, but we normally use SAPSS, and some even use Excel and other, but with SEM, I'm not so sure about. I wouldn't want to answer it because I've never used it, but it doesn't mean.
It could just be the standard error of the mean, maybe.
Yeah, if it is like that, yes, the standard error of mean, it is used because we use when you remember on the equation, there is the way we measure the error of mean at 0. So I think it is possible, but I still use I think, because the question is not very much clear to me.
Okay, so if once again, if that question could be asked again more clearly, and we can answer it once more. Please, can we also get the tutor's email so that we can ask further questions when faced with more details on the modules? You can always ask your own tutor for further details, or in the Q&A here. Yes. We don't normally give out the emails of the people doing the seminars themselves, but again, you can always inquire at the doctoral school in case there might be an exception or a different policy sometimes. So, a couple of people thanking you for doing a very good presentation. And again, the question of when the recording will be available, because some people have network issues or they're unable to attend. Yes, it'll all be up on the VLE within a month by the end of February, by the end of this month, April. So you can just find it there, video and all the videos in this series, in fact. So the next question, if you do have any more questions, please post them in the Q&A. The next question is, how do we solve the problem of heteroscedasticity when we run a regression?
Yes, normally when you're using, with the new technology, this is a little bit better now than what we used to do when we used to do it manually. Like we talk about heteroscedasticity, that one is very difficult to pronounce. It happens when the standard deviations of a predicted variable, like monitored over different values of individual, is related to prior times. And this can be tested also because it's a random variable which is very infinite, and this is known also as homogeneity. So normally when you use, as we encourage now for the error to be less, when you use the SPSS, there are tables and graphs which will come out, which will show you the heteroscedasticity of this. And then from there, you can now interpret it. As I said, I'm not going into very much into detail. I'm not teaching statistics here. I'm just giving you a guide. So when you use SPSS, you will go there, they will bring out all the heteroscedasticity of the variables which you would have put in, and then from there you can interpret.
Okay. How can one get SPSS to install for practice?
That one, I think, Sebastian, you can answer for me.
I don't know. I've never installed it.
No, that one, I think you have to pay for you to have access to that. Because for practice, but I'm not so sure. You will find that there are some people who, if you can manage to buy it, it will be best because it can go for some time. It's got subscriptions. But just for practice, I don't know if you'll be lucky to get it from somewhere, maybe from friends. That's what I can just say, because this software, you have to pay for it to use it.
Yeah. Although there are alternatives that you can use instead.
Yeah, like what I said, you can always start off with an Excel. Also, Excel brings out, but it's not much like detailed like SPSS. But if you can't afford SPSS, it will be best also to use Excel, which is already on Word, which you have on our computers or laptops at the same time. So there are others also which are cheaper. If you Google, you will find a lot. But SPSS, you normally have to subscribe.
We've got a suggestion that the recording be sent in emails. It would be nice, but we can't actually send recordings by email because they're too large as a file. So you can't send them through most email programs. You could send them as a Google Drive link, but in practice, we put them on the VLE and you can check them there. So it's very easy to do. If you don't know how to use the VLE or how to access the Help Center, you can always send us an email inquiry and we can send you instructions. But no, we can't send them by email, unfortunately, no. Any more questions from anybody? Okay, if there are no more questions, then unless you want to cover anything else, Dr. Mandiringana, I think.
No, I would like to thank all the participants for attending the seminar. And I hope that in the next time we'll be looking more deeper into the regression. And there are a lot of types of regressions, like the one was talking about logistics, and help also the students in the way they face their bit heavy issues with the regression and correlation. But after this seminar, I hope it will help them. Thank you.
Any specific dates? Sorry, one more question. Any specific dates to expect information on the VLE? In the last 10 days of April, because we've got the UBRAC conference coming up next week. So it's unlikely that they'll be edited not before then. But in the last 10 days of April, I'll be up on the VLE. The first 4 are already there. Okay. Thank you very much, everybody. Thank you for attending. Thank you, Dr. Mandiringana, for a very interesting seminar and for the Q&A section. Whoops. Another person saying thank you. Okay. So we're all good. I'm going to end the webinar now.
Okay. Thank you, Sebastian.
Thank you. Good meeting you all.
Bye. Bye,
Bye-bye.
everyone.